This is a brief introduction to the INSERTA family of slip-in check valves. INSERTA offers a very broad size range of these valves in a nominal size range of 1/8 inch to 3 inches, corresponding to nominal flow capacities of 2 to 400 gallons per minute. We have been producing these valves for over 3 decades, and they have found use in a myriad of applications at customers around the world. These valves may be used in applications requiring an axial or straight through flow path or a 90-degree flow path more typical of a hydraulic thread-in cartridge valve. The valve is offered in 2 varieties, a standard unguided disc valve and a guided disc valve. For clarity, the valve body of the guided disc valve is cut away. I have also included an example of each valve's disc and seat beside each valve. The standard disc type valve is available across the complete size range and is suited to most applications. The disc is unguided and affects a metal-to-metal sealing interface with an opposing valve seat. Both are in a hardened condition, with the seat slightly less hard to allow the disc to wear in over time. The sealing surface of both the valve seat and the valve disc are flat lapped on one of our 3 production lapping machines to a flatness within millionths of an inch. This results in a typical expected valve leakage of less than 1 drop per minute in the check direction at the valve's pressure rating. For challenging applications, INSERTA has developed the IGS, or guided disc check valve. Here is an example of a guided disc valve and seat. The guided disc is outfitted with a cylindrical guide that runs within a corresponding bore in the valve body. When the differential pressure of the fluid between the upstream and downstream side of the disc exceeds the valve cracking pressure, the valve opens, permitting flow between the disc and the seat, around the disc, and then through the exhaust end of the valve. When the differential pressure falls below the valve cracking pressure, the disc is urged toward the seat by the spring and the valve closes, preventing flow in the opposite direction. The flow areas of the INSERTA slip-in check valves are generous when compared with a typical screw-in hydraulic cartridge valve and result in favorable pressure drop profiles. This can be used advantageously to reduce waste heat generation or even reduce the power requirements of the prime mover. Here is an example of valve operation using our cutaway IGS valve. The IGS guided disc valve offers superior longevity in applications subject to severe turbulence, particularly with the valve operating in a partially open state in a turbulent fluid stream. In an unguided disc valve, this can potentially induce a phenomenon known as valve disc flutter, where the hardened disc oscillates in the turbulent fluid stream. Over time, the hardened disc can induce wear in the valve body and seat. This is most often seen in larger size valves, nominal size 16 and above, and valves with a 3 psi cracking pressure spring. The lower cracking pressure springs have low stiffness and can result in large amplitudes of valve disc motion, as opposed to a stiffer, higher cracking pressure spring, where flutter amplitude may be minimal. The trade-off to using a valve with a higher cracking pressure is that it takes more flow to fully open it. Here's a flow versus pressure drop curve for the IGS A20 valves, including a 3 and 15 psi cracking pressure spring. The valve with the 3 psi spring is fully open at just over 20 gallons a minute, while the valve with the 15 psi spring is not fully open until over 50 gallons a minute. The first part of the curve is linear. As the valve opens, the flow area through the valve is gradually increasing as the disc moves further away from the seat. Once the valve is fully open, then the flow area is constant, and the flow versus pressure drop obeys a power curve. The IGS guided valve is also helpful in applications that may see flow transients that greatly exceed the nominal flow capacity of the valve. such as sudden rush of fluid in an accumulator circuit, for example, can cause the valve to slam open with considerable kinetic energy upon impact. The effects of this can be amplified if the valve impacts at attitude, and over time, the hardened disc can induce wear in the valve body or seat. An example of this in an unguided ICS check valve is like this. The guided disc forces the disc to open and close at normal attitude, greatly increasing valve longevity. Also, fluid needs to move out of and into the spring chamber during valve opening and closing through an orifice. This tends to limit the terminal velocity of the valve disc at full open and full close, which results in lower kinetic energy at end of stroke, which again significantly improves valve longevity. For larger size valves, size 16 and above, the guided disc valve is more suited to a 90-degree flow path, that is axial flow at the inlet and radial flow at the outlet. Cavity dimensions and pressure drop curves for both axial and axial-radial flow applications may be found on our website. No special cavity form tools are required. We also offer the ICVR check valve retainer that may be used to retain the slip-in valve in a cavity for axial flow applications, and the IGSP retaining plug assembly, which may be used to retain a valve in an axial-radial flow application. Incidentally, the cylindrical guide on the guided disc lowers the stress in the valve disc significantly. The IGS valve is formally rated through testing at 6,000 psi with a 4-to-1 safety factor. However, typical disc stresses are low enough to support a much higher working pressure. Please contact us with any higher pressure application. With the exception of the valve discs and springs, the ICS and IGS valves are identical and are interchangeable within the same valve cavity. In summary, the INSERTA slip-in check valves offer the circuit designer significant opportunities to save space and lessen wasted energy consumption and waste heat generation over a typical screw-in cartridge valve. They may be used in either axial or 90-degree flow path configurations. They are robust and offer favorable minimal leakage in the check direction through sealing using lapped and hardened valve discs and seats. Thank you for considering them, and thank you for watching. Please watch our other product videos available on our website at www.inserta.com.